Breaking the wall of space debris. Mars Buttfield-Addison. Falling Walls Lab, Australia.
Hi, I'm Mars, and I'm working on breaking the wall of space debris. Space debris refers to the accumulation of rocket bodies, dead satellites, discarded space station components, test spacecraft, and fragment debris in orbit around Earth. Most of us don't think about space debris day to day. It hasn't caused us significant grief in our daily lives yet, so it feels like there are more pressing issues to worry about. But many are not aware of all the critical services we only have because of satellites in orbit. Satellites that share their orbits with an increasing amount of dangerous craft. So it's kind of like our plastic pollution of the oceans, except if all of a sudden one day without warning that accumulated plastic would somehow take out our communications networks, and our maps, and our disaster early warning systems. That would be bad. In fact, the leading expert in the domain thinks we've already been a decade overdue for this to happen. It's just that the luck has been on our side thus far. There are lots of ideas about how we could get the junk down, from grabber robots to lasers, but these approaches rely on cleaning up millions of fragments in orbit, piece by individual piece. So more and more, the only thing between us and a cascade collision disaster in orbit is monitoring. A global collaborative effort where sensors around the world look to the skies 24/7, detect where debris objects and satellites are, and run complex models to predict if any are going to collide. If an alert comes in, we tell the satellite operator to move their asset out of the way. But today we're launching 10 times more objects into orbit than we were a decade ago, and the sensors we have just can't keep up. So if we can't afford the time or the money to build new space tracking radars as fast as we're putting junk into orbit, we need to look to what we already have. My work looks at existing sensors built for other purposes, such as radio telescopes built for deep space astronomy, and what kind of hardware and software adaptations are required for them to monitor space debris. That's technical work, but there's also a human aspect. These sensors already have important work to do, and their operators aren't just going to stop all that so we can look at space junk. What if we could do both? One of the systems I'm working on is a commensal backend, which means it can run in the background of a telescope's regular observations and detect signals and reflections off of debris and satellites that have passed by in the foreground. This required the development of novel algorithms and system architecture to address 3 layers of complexity. First, the usual complexity that comes with monitoring the skies, accounting for Earth's rotation during observation, pointing error, and noise sources. Second, the complexity of looking nearer to Earth, which requires the telescopes to be able to focus while effectively cross-eyed. And third, the complexity of interleaved observation, where observed sources have to be distinguished from deep sky versus near-Earth observations. This specialized software can then run in existing back-end processing systems or on easily obtainable consumer computing hardware. And by modifying existing radio sensors around the world in this way, we can add more than enough tracking capacity to address space junk monitoring and prevention into the future, all without interrupting anyone's work and with minimal requirements for new components, to ensure that future generations can still benefit from space as we do today. Thank you.